Right, can we start now? I think so. Right. Good evening, everyone. Tonight, I'm going to talk about some of the best practices of using ARM template. So many people have already talked about the ARM template stuff, how to use the ARM template in a best practice way or something like that. So I'm not gonna touch everything in here, but instead I'm gonna talk about a few things we might need to consider, and from my the client engagement. So my name is Justin from Maxia as a senior consultant, and I'm a Microsoft MVP for Azure and .NET, and particularly in DevOps area. So this is my Twitter, blog, and LinkedIn profile. So if you are interested in, just follow me here. And yeah, before starting, I'd like to ask a few questions about the ARM template. So do you actually use ARM template for your work? How many of you? Yeah, okay, only a few. And so if you are using ARM template, do you integrate actually ARM template in your build and release pipeline? Okay. So yeah, so if you have been using this kind of ARM template for your work, probably you might have heard a lot of the best practices around here. So tonight, I'm going to touch about those things, why we need to use ARM template, and how we can write ARM template, how to test it, how to deploy it to the Azure, and finally, I'm going to touch about how to manage the ARM template deployment history. So it's a kind of a bit of a rush, so bear this in mind. So why do we use ARM template for our the Azure resources? So the ARM template, ARM stands for actually Azure Resource Management. So basically, the core of Azure Resource Management is using the resource group. So resource group is the logical the grouping of all the Azure resources. So the all resources we are defining goes into a certain resource group we are grouping. So this is the resource group logically, and this is not relevant to any of the physical location. And also, if we use the resource group, and it's also good for the lifecycle management of all the Azure resources, because we create the Azure resources within the resource group from the creation to disposal. So if we don't need any of the resources within the resource group anymore, and simply delete resource group, then all the resources in that resource group can be deleted at the same time, so without any other the effort. Before using ARM template or as a resource management, and we have to find all the resources one by one and delete it, but now we don't have to worry about that. And also, if we use ARM template, it's also good for the reusability, because so think about you are as the DevOps engineer, and you are managing all sorts of different environments. So if you create the one infrastructure for development environment, and test environment, and production environment over and over again. So if you are managing only a few Azure resources, that's fine. But if you are managing hundreds of thousands of Azure resources, and that's going to be a problem. So in that case, if the ARM template is very useful for that. And also, we have to clearly define any of the Azure resources in ARM template. So in other words, if we don't define any resources, it cannot be deployed. So we have to clearly define it. So it's kind of a good thing. So we know what exactly which resources has been deployed to a particular environment. Also, we can define the dependencies between the Azure resources. For example, let's think about the Azure App Service instance and Azure SQL database. So usually the SQL database provide a connection string, and the app service environment to use that in their the app settings. So if there is no the Azure SQL database, Azure app service instance cannot get those kind of connection strings. So it has to be deployed the Azure SQL database first, then app service instance later on, something like this. So by doing so, we in Azure the ARM template, we can set up those kind of dependency so that the Azure SQL database is deployed first, then app service instance is deployed later on, so that we can get the connection string within the ARM template properly. Also, the individual Azure resources, including the Azure subscription and the resource group level, support the role-based access control natively. So which comes from the Azure Active Directory. So for example, so we can set up the different the access policies in a different group. For example, if your company has a different team, for example, the infrastructure team and the development team. So infrastructure team has their own the resource group. They are which is controlling all the virtual machines, all sort of stuff, or container stuff. And developer team, they use their app service environment, app service instance, something like that. So developer team doesn't have to access to the infrastructure resource group anyway. So something like that. So we can actually physically set up the access policy on the particular resource group, so that those kind of the people by accident access to the wrong resource group and some kind of misbehavior happening. We can prevent those kind of things. And also, the Azure resources support tagging. So tagging is just for just tagging, but it is good. It is beneficial if we actively use tagging, because it actually identifies who is the cost center of the particular the Azure resources or resource group. So at the end of the billing cycle, we can identify, okay, this the Azure resources were used by some the cost center, and the other one was used by the other cost center, something like that. So this the tagging is very useful for that. So what we are touching as a best practice tonight is actually you don't have to follow. So if you think this is not necessary for your situation, and actually you don't have to follow. But if you think that's is actually good for your situation, and it will make your life very easier. So, and also there are more best practices out there. So take your time to do your own research. So you can combine what I am saying tonight and with the other best practices together. So yeah, I'm going to talk about the writing ARM template stuff first. So yeah, we are talking about writing, testing, deploying, and the management. So first thing is writing. So think about the YAML. So you know the ARM template is basically the massive size of JSON object, right? Which has a complex structure. So if it is relatively small, that's fine. So if you are the writing or that ARM template is only taking care of one or small resource, one resource, that's fine. But if that ARM template grows up and takes care of many resources at the same time, and then the JSON object structure will be very complicating, very complex. So then eventually it's very hard to read, right? But on the other hand, if we consider YAML, and it will be very different, right? So YAML is actually the superset of JSON, so we can easily convert from YAML to JSON or JSON to YAML, right? So you know, the ARM template doesn't support YAML officially yet, so it's just some kind of a different approach. So yeah, think about this picture. So can you see the picture at the end? Yeah. So this is the typical JSON the object, right? It's the typical ARM template written in JSON object. So can you identify so many the curly braces, and even there is the square brackets in there? And probably, if you see there, there is a square bracket here. Right? It's very hard to find. So it's just this ARM template is only for the virtual machine setup. But if you have multiple resources in here, and if there are more depth in there, and you will be able to find defining those brackets and the braces very hard. So on the other hand, think about this. The same ARM template, same thing, same setup, but it is written in YAML now. Right? So this is written in YAML, and it actually removes all the curly braces or square brackets and so on, but has the same structure. Right? And from the readability point of view, the right-hand side in YAML is much easier. Right? So, consider writing the ARM template in YAML, and when the time comes for the deployment, simply convert YAML into JSON format, and we can start deployment from there. So the reason I suggest is to use YAML is more human readable. Also, YAML supports comments. On the other hand, JSON doesn't support comments. Sometimes we probably need to put some comments on there on each line to describe something, right? So so YAML is definitely to go. And if you are using the Visual Studio Code, there is a very useful extension called JSON to YAML. So if you are using that, just simply install that. Then you can use easily convert the JSON to YAML. So this is how YAML and JSON are easily converted from each other. So it's just a single the shortcut key, just convert from one to the other. Also, when you're writing an ARM template, the YAML, so that's the authoring point of view. And now we are talking about the when you finish writing in YAML, and you need to actually convert that into JSON format. Right? So that's the small the utility command line tool called YAML CLI. So it actually convert ARM template written in YAML into JSON. So this is the GitHub repository for the YAML, YAML CLI, and this is a cross-platform tool. So you can use the written in .NET Core. So you can use this one on any of your build or release pipeline on any OS operating systems. So if you are, this is the GitHub repository URL. So if you are interested in, go and have a look at that. So I'm going to show how the YAML CLI works. So I took this short video for demo. So there are only two parameters, input and output. Very simple. So if I already have the YAML, the ARM template in YAML. So so this is what YAML look like. Actually, the ARM template is for to deploy the request bin application onto Azure using the Azure container instance. Now, so I run. I already passed it. So I run the YAML CLI to convert from YAML to JSON, and this is the result. So YAML has already changed to the JSON format, and so from here we can simply use this JSON formatted ARM template for our deployment purpose. So and this YAML CLI, that's a small the console application, so it's very easy to integrate your CI/CD pipeline. So I took the screenshot from VSTS. So first of all, we need to install the YAML CLI, then do some other bits and run the conversion stuff for individual the ARM template, which is written in YAML. Then do testing, do deployment, whatever we want. So if you are interested in more about the how to write the ARM template in YAML, and visit this the blog post that I written, it will have more information if you like. But another part of the writing ARM template is about the relationship between variables and parameters. So this is some basic ARM template structure. It has the 5 different sections, which is parameter, variables, functions, resources, and outputs. So resources section is the only mandatory field, and the other ones are all optional. Now, the relationship between parameters and variables, what we are talking about is we should use parameters to pass variables from pass values from outside. Right? So the parameter section is only used for the communication or interaction from outside. Right? And these the values from parameters should pass into the variables. So I would suggest not to use parameters directly into the resource section. So we pass all the values from the parameters to variable section, and variables that variable section to manipulate all the parameters and do some the internal processing. Then we use those values in the variable section to deal with all the resource as resources, which is defined in the resources section. Right? So yeah, in other words, the values outside should come to parameters. Then those values should be passed from parameters to variables, and resources only need to deal with those values within the variable section rather than parameter section. The reason behind is if we use the parameters value at the resources section, and if there is something goes wrong, then we have to scroll all the way up to the parameter section, and if we find something wrong, and then we have to scroll all the way down to the resource section to fix it. So it's kind of very inefficient. But if we only take care of, if we only use variables for the resource section, we don't have to scroll all the way up to parameter section. We only take the variable section only. If there is something goes wrong, and we just fix it there, right? So it's all about the efficiency and productivity. So I would recommend use the variables only for the resource section. Now, so probably you might be curious about this number, 256, which is the maximum number of parameters and maximum number of variables in one ARM template. So I'm pretty sure this is very rare to exceed this number in one ARM template, but we never know. So and if we use a linked ARM template or something kind of complex one, it's probably likely to exceed this number. I have a few cases that has already exceeded this number. So in that case, we probably recommend using the object type of the values or parameters in that case, something like this, rather than string or integer or something. And the function is a kind of not popular, less popular than other the sections. So what function does is it's actually we can define custom function within the ARM template. So within that function area, right, we can simplify some kind of complex expressions, right? And also this is this works as a function, so we can reuse this function over and over again within the one ARM template. What that means is when we use ARM template and when we parameterize ARM template, like we usually follow the naming conventions, right? So that naming convention usually include where the the resource location is, where the resource the type look like, or something like that, right? So those kind of things are all parameterized, and this can be very complicated in the string from the string concatenation point of view. So if we introduce that function, this function, to simplify those complex expressions, that would be a very useful. So yeah, I intentionally write this the function part in YAML. So functions can have the multiple. Function is actually accepting arrays. So each array has is an object with a namespace and the individual functions. And function takes the parameters, and the function returns a value. But when you see the parameters here, so these parameters comes from here, right? So looks exactly the same as an ARM template function, right? But we cannot use ARM template function within this the function. So this is the only caveat of using the function, the custom defined function. So bear this in mind. So what that works is it get the full name parameter string, and which contains the placeholder, and that placeholder is replaced by the suffix, something like this, right? So this has the namespace with member. So the purpose of using namespace is to avoid any possible conflict with other functions or other existing or predefined functions. So this is how we can use the function, user-defined functions here. So this is a variable section. So we define the full name, and we pass that full name into that function with those kind of suffix. So function app have all the same the structure with different the suffix, and logic app will have a different suffix. Service bus will have a different suffix, but the overall structure will are very similar to each other, something like this. So yeah, this is kind of very useful. Also, when you finish deployment of ARM template, and you will get the result of what the result of the ARM template deployment is. So in that case, we can introduce outputs, right? And outputs is one of the the ARM template structure. So this is particularly useful when you build when you integrate this ARM template into your CI/CD pipeline. So the previous the ARM template deployment task will return something, and that returned value can be used the followed the task. All right. So now we are moving into the testing stuff. So when you write the ARM template, do you actually test that ARM template before actual deployment? Yeah, we should. There are the PowerShell commandlet called the test something. So that's actually validating the ARM template structure. So if the ARM template is valid, it returns nothing. If something goes wrong, it returns an error message, something like this. But it's all about validation. But validation doesn't mean we are properly deploying the correct resources, right? It can be we probably make a mistake to use a different SKU or different locations or different naming standards, something like this. So validation cannot capture those kind of the errors. So in that case, I would suggest to use the Azure CLI. So this is the commandlet, PowerShell commandlet, right? So if we run this, unless there is no error, it returns nothing. But if we use Azure CLI command like this, it actually returns a JSON object, regardless it's successful on error, right? So, and this is because this is very good for the testing purpose, because it is very good for error handling, right? So if you are running the PowerShell commandlet, and usually when the PowerShell commandlet throws an error with the blue background with the red scary the error message, which is not very helpful. So in that case, there there's not much space we can do further. But if we run the Azure CLI command for the validation, it actually returns an error or the validation result. So by using this kind of the validation result, we can actually test how that ARM template will behave in certain manner. And also, if we want to test those kind of behavior, I would suggest using Pester. So Pester is the PowerShell test framework, and using the BDD style of testing script. So this is how the Pester script look like. So yeah, it's a very typical the BDD style. So we describe and we define context, and within the context we run the Azure CLI command, and after that, with that result, we check the expectations. It should do something, it should do something, and if there's something that we don't expect, and the test will fail. All right. Yeah, this is the actual test script I have written for using Pester. So in here, so within the context, I run the Azure CLI command, and it returns actually the JSON object. And with that JSON object, with a validation result, it actually, yeah, we can actually check if we check this, the ARM template deployment will be successful, and it has the expected naming standard structure, or we can further check it might have expected location or something like this. Right? Now, yeah, the previous one is how we write the Pester PowerShell script, and this is the actual the run result from the script run. So yeah, pretty similar to the other the testing framework, and it also stores saves the test result. So in certain format, and that kind of a result can be easily integrated with the preferred the build pipeline, so that we can see the test result like this. So if you are interested in more about the ARM template testing, visit this blog and have a look at that. Now we finished testing. Then moving into the ARM template deployment. So I would suggest to use one ARM template for one resource, one single resource, which is, yeah, we already know the single responsibility. But it also uses, it's not just for single responsibility, it's also for the reusability, which means we can separate all the Azure resources in individual ARM template, and later we can combine all together for through like a linked ARM template or build the CI/CD pipeline. And of course, there are exceptions. Something like the app service instance should always come together with configuration settings or something like that. So without those the exceptions, yeah, I would really suggest to separate all the Azure resources into a single the ARM template. Right? And I kept mentioning about using the linked ARM template, but from my perspective, I would really recommend using a linked ARM template very consciously and carefully, because it's very good. I'm not denying this is bad and this is good. Am I correct? So yeah, so linked ARM template is good, but it has also our own limitations. The first thing is we have to upload the child ARM template to publicly accessible place, like a GitHub or the blob storage with a SAS token or something like that. So if I want to test this linked ARM template in my local, it's something like I have to access to somewhere else in the public. So I have to upload the child template first, so which is an extra step. So from that kind of view, that point of view, it's not that good for me. So if, do you have any question?
Is there any way with YAML to split them and then let YAML combine and generate like the large template in JSON?
You mean your question is the separate YAML template to combine one big ARM template?
Yeah.
I haven't tried that.
Instead of linking, if that is an issue with linking, you can work around it with YAML, speeding up the YAML.
Oh yeah, that's a good idea. But I haven't seen those kind of functionality. And the YAML CLI is simply convert the one single YAML file into the JSON object. So yeah, so that's I think that's different the purpose. But I think it's a good idea. Probably we can find out how we can do that. Yeah. So as I said, if we use the linked ARM template, and it has also has its own limitation, as I said. And one of the the limitation is we cannot use both the parameter object and parameter file at the same time. We have to choose either parameter object or the parameter file. And this is usually, in most cases, this is not the case. The reason is sometimes we need to pass some sensitive information, like the authentication keys or access keys. That shouldn't be stored into parameter file, right? So in that case, we usually pass parameter file, and sometimes we overwrite some of values by providing the parameter values individually. So in that case, we cannot use a linked ARM template because we have to choose either parameter object or parameter file, right? So unless the linked ARM template solves this problem, I wouldn't recommend using the linked ARM template. Or you can just simply give up using parameter file and put everything into the parameter object. That may result in 256, the maximum length. Right? So instead of using linked ARM template, I would really suggest to let the CI/CD pipeline take care of those the linked ARM template the features. So which means actually linked ARM template orchestrate the all other child templates deployment. So why not CI/CD pipeline take care of that? So as long as we properly define the order of the ARM template deployments, then the result will be the same. But still has this still has the caveat because the linked ARM template can support that linked ARM template support parallel execution of deployments. On the other hand, the CI/CD pipeline, unless it is supported, natively supported, it only supports the sequential the task the management. So, but from the performance point of view, I don't see any huge the demerit of using the CI/CD pipeline. So yeah, usually when I go to my client side, I usually suggest using the CI/CD pipeline for the individual ARM template deployments rather than linked ARM template. Now, yeah, that's the last bit. I'm going to talk about the deployment history management. Do you know the number 800? What is this?
Maximum number of deployments for a resource group?
Yeah, that's right. So each resource group can have up to 800 times of deployment, which means if you deploy 800 first times of deployment, you will see this error. So which says the access quota of 800. So in this case, in order to avoid this error, we have to remove some of the deployment history before exceeding the threshold. But it's also a good idea to store that kind of the deployment history somewhere else before removing it. maybe it is because we might have to the auditing for what kind of deployment history look like, right? So yeah, so in this context, we need to remove the deployment history as well as store that history into somewhere else. And if we are using the PowerShell script or REST API to delete the deployment history, so individual deletion takes at least 30 seconds to 60 seconds, which very long. So if we use PowerShell, it takes more than 6 hours to delete entire 800 histories because it doesn't support parallel execution for each. So if you don't like the writing code for that, LogicApps is actually LogicApp is very good for this the execution. So the for each loop in the LogicApp support parallel execution up to 50 times. So it actually dramatically reduced the time to less than 16 minutes. So from 6 hours to 16 minutes is very efficient. Now, this is how the LogicApp structure look like. So first of all, we read all the deployment history and loop through that deployment history, store into the table storage, then delete it. Right? So this is the how LogicApp look like. Now, so yeah, so if you are interested in the management of deployment history and yeah, find this URL, then you will follow. You will get more details on there. Yeah, so almost done. We have covered why we need to use ARM template for our the Azure resource management, and we have covered writing, testing, and deploying ARM template, and finally we covered the ARM template deployment history management. So that's it from me. Any questions?
I noticed with your testing, you're using PowerShell.
Yes.
Is there not an equivalent function in the C# API or something like that? Like in my experience, I try and get away from PowerShell as much as possible because it kind of works until it doesn't, and then you don't know what the hell's going on. Mm-hmm. Whereas the C# API generally sort of is a bit more predictive in the behavior. Mm-hmm. Have you looked at that? Or?
That's a good question. So your question is, can we avoid using the PowerShell for the ARM template testing, right? Yeah, yeah we can. I haven't looked at that yet, but actually the testing, I mean the Azure CLI, both Azure CLI and PowerShell command uses the REST API of the Azure resource management. So as long as we can call that API, get the return value, and that would be fine to using the C# code or whatever. Yeah, I like that approach too. Yeah. Any other questions? Yeah, yeah, that's fine.
Sorry, I was actually
that's fine. That's fine.
You prefer using YAML for the instead of the JSON.
Yes.
It's more readable. Do you consider the YAML or the JSON to be like the source of truth there? Like which one do you actually store in source control? Do you store the YAML and just have a translation layer in your build pipeline, or do you go like, well, the JSON's actually the source of truth because that's actually what we emit to Azure and that's meaningful to Azure, and do we just make it so that the tooling itself, kind of the JSON's like a generated thing, and when you go to pull that into source control, you've got some sort of tooling in like Visual Studio, whatever, converts that to YAML, you manipulate the YAML, and then you've got like a hook that just generates JSON again. Like what, have you sort of tried both approaches, or do you just prefer working, I guess, in YAML as a source and then just translating the pipeline?
So your question is about how do I deal with the ARM template in as a source of truth? And I actually, so whenever I go to my client site, and if they are already using the JSON, then mostly they do that. But if this is a new project and I am the initial beginning member of that project, I always go to the YAML. So YAML is a source of truth, and then it's actually easily convertible into the JSON format, and those kind of conversion is taken care by the build pipeline. So I don't have too much worry about the JSON object itself.
Right.
Yeah. And the caveat is the IntelliSense doesn't support it. So if we keep using JSON objects, and then Visual Studio Code or Visual Studio can support those IntelliSense stuff, but YAML, no official support. But if you are already familiar with writing the ARM template, you already know all sort about the functions or structure. So I would go for YAML. Any other questions?
When writing the templates,
Yeah.
what's your best approach for trying to reverse engineer existing resources? Because I find a lot of times the automation script in Azure, that it just spews out junk.
Mm-hmm.
So it's quite noisy.
Mm-hmm.
Is there any other way of getting nice, clean templates out of Azure for existing stuff? Or do we just have to do the hard work and clean it up ourselves?
Good question. So your question is where is a starting point of writing ARM template? Is that your question?
Yeah, so from existing resources in Azure,
Mm-hmm.
you want to mimic that
Mm-hmm.
into an ARM template.
Mm-hmm.
What's the best way to really do that?
Interesting.
I mean, it gives you more than what you need sometimes, a lot of properties that you don't want to, a lot of defaults are there. Excuse me? Or missing, yes, that too, yeah.
You can start. So you can start from the blank ARM template, or I usually, if I create the new new Azure resources that I have never worked at before, and I usually go to the Azure quick start template. So on GitHub, so we can that's a very good starting point, and you can. There are a bunch of very similar the ARM templates. So, for example, there are like 15 or 20 different style of app service instance, for example. So you can choose. You can have a look and then start from there. And then the YAML CLI that I introduced is actually just type the URL, then it gets actually the convert into YAML straight away. Then you can start from there. Any other questions? No more? Right? So my company, Maxia, is always looking for the Azure expert. So if you are interested in, come and see me, and we can start discussion from there. Thanks for listening.